Okay, this worksheet is going to help you practice some theoretical probabilities. There are 5 multiple choice questions on this worksheet. My suggestion to you would be to either work along with me or maybe we'll read the question together, hit pause, try the problem on your own, and then you can turn it back on and check with me. If I don't say hit pause, I'm going to try to say that to give you a reminder, but if I don't say hit pause, that's something that you could do on your own. And I'll also try to give you a hint so that if you hit pause, you try it on your own and you don't know what to do, you can hit play again. I'll give you a hint and maybe you could pause it again and then see if you can get it on your own. Okay? So our first problem, if 3 nickels are flipped at the same time, what is the probability that all 3 nickels will show tails? So you can hit pause and try it on your own. If you've turned this back on or if you just kept listening because you don't know what to do, my hint to you would be to make a tree diagram because there are more than 2 events happening at the same time. Okay, so I'm going to walk you through how to make a tree diagram for this. It says our 3 nickels are flipped at the same time. What's the probability all 3 nickels will show tails? So the very first thing that can happen when my experiment starts is I will flip my first coin. When I flip my first coin, I have 2 options. I can either get heads or I can get tails. Let's say I flip it and I get heads. When I flip my second coin, I can either get heads or tails. But what if when I flipped it the first time, this is our first flip, if I would have flipped it the first time and gotten tails, on the second time I could have still gotten heads or tails. Maybe I should do those in a different color to show you the different flips. Okay, so I'll make the first event in purple. I'll make the second event in green. So my second coin is in green. I could have flipped that and gotten heads or tails. Heads or tails. Okay, now I have a third coin to flip. And when I flip I could flip my coin and get heads. Flip my coin and get another heads, or I could flip my coin a third time and get a heads or a tails. Or I could have done heads on the first coin, tails on the second coin, then heads or tails on the third coin. And then same, I'm going to add another heads or tails off of each of these. Okay, this problem is usually one that really confuses people. So I'm going to write out all of the different things that could have happened when we would have done this experiment by looking at my tree diagram. So the first thing that could have happened is I could have flipped heads, heads, heads. So over here I'm just going to write H, H, H for the 3 heads. Or I could have flipped, remember it goes first is purple, second is green, third is blue. So if I go purple, green, blue, now I go heads, heads, tails. So I'm going to write that. Heads, heads, tails. I'm going to still go purple, green, blue, but now I'm going to go heads, tails, heads. So I'm just making my way down the chart, down my tree diagram. Then it goes heads, tails, tails. So I've done the first 4. Heads, tails, tails. Then tails, heads, heads. See if you can pause this, try the last 3 on your own and see if you can get them. Okay, I'll write my last 3 out now. Tails, heads, tails. Tails, tails, heads. And then tails, tails, tails. The reason we make the tree diagram is so that we don't actually have to think through all of these examples in our head or all of the possible outcomes. So the tree diagram just kind of gives us all of them at once. So if we look, there were a total of 1, 2, 3, 4, 5, 6, 7, 8 total outcomes. The way you can find this on your tree diagram, you count all the ends of the blue branches of your tree diagram. So it would go 1, 2, 3, 4, 5, 6, 7, 8. Okay? One outcome is like one path on the tree diagram. Okay? So you always end up this last row or this last layer, which is blue. So anyways, there are 8 total outcomes. Let's come back to our question here. What's the probability that all 3 will show tails? So how many times did I get all 3 tails? That was just 1 time. So it was C, 1 out of 8 times. 1 tail out of 8 total outcomes. Question 2. How many possible outcomes exist if a 6-sided die is rolled and then a spinner with 3 sections is spun? Okay, I'm going to see how many events I have here. Remember, 1 event, well, that's just easy. We just write the probability. 2 events, you can make an area diagram. And then 3 events, you need to make a tree diagram. So you could make a tree diagram for just 2 events, but most of us usually like area models better. So I'm going to look and see, I roll a dice, 6-sided dice, and then spin a spinner with 3 sections. Since I just have 2, I'm going to make an area model. So I'll do this color-coded for us. One side I'll do purple, and then the other side I'll do blue to show us each of the events. Maybe I'll finish it off with green here. Okay, so my first side is my 6-sided die. So just think, if you go to roll a dice or roll a number cube, what could you get? And I'm just going to say I can get a 1 through 6. So 1, 2, 3, 4, 5, 6. Okay, now when they tell us the spinner, it has 3 sections are spun. So I'm just going to say spinner down here with 3 sections. Section 1, Section 2, Section 3. Okay, now if you have Mrs. Hardy in class, she'll say you need to slice and dice this. So slice it this way, so I can split it up into 6 sections. Sometimes Mr. Bubonics will remind you, if you split it in 6 sections, that means you draw 5 lines. And then dice it. Since we sliced it, now we dice it. And if we use what Mr. Booth says, that means we only need to draw 2 lines because we're splitting it into 3 sections. Okay, so let's come back to our question, and it says how many possible outcomes exist? Well, we could either count them all, 1, 2, 3, which would be a little time consuming. It'll always get you the right answer. Or we can just multiply 6 by 3, which is 18. D. Question 3. What is the probability of tossing a coin and getting a tails, then rolling a die and getting an odd number? Okay, so maybe hit pause, try this on your own. If you need a hint, my hint to you would be to count how many different events we have happening, and then go from there to either make an area model or a tree diagram. So I'm going to look here and say the probability of tossing a coin and then rolling a die and getting an odd number. So I see that I had 2 things happening here. So I'm going to say one side is rolling a die, and then the other side is tossing a coin. So I'll put down here coin and the dice, or die, which is singular for dice, even though it sounds kind of yuck. Okay, so when I roll dice, remember it's sides 1 through 6. So 1, 2, 3, 4, 5, 6. Now the tricky part, don't forget with the coin, is that when you flip a coin, even though it has 2 options, one option is heads, the other option is tails. So that's what you want to put down here, an H and a T to represent the heads and the tails. Okay, so even though there's just 2 options, don't put a 1 and a 2. Okay, I'm going to just finish my chart, finish my area model rather, and now I'm going to slice and dice, slice with 5 lines, and dice with 1. Okay, now it asks me here, what's the probability of getting a tails and rolling an odd? So I'm just going to go through and write in all my options. So this one would be a 6 and a heads. So I'll say 6H, 5 and a heads. So I'm just going to go through and fill out the rest of this table. You do the same. And then my 6 and tails, 5 and tails, Okay, so I'm looking for an odd number and tails. Well, this is the only column with tails in it, and I'll maybe circle my odd numbers. 5, 3, and 1. So altogether I had 3 out of how many choices? 2, 4, 6, 8, 10, 12. 3 out of 12. Well, remember, we always need to simplify. We can't just leave it like that. So both of these numbers are divisible by 3. Obviously, 3 is divisible by itself, and 12 is divisible by 3. So I'm just going to rewrite this as 3 times 1. I'm going to rewrite 12 as 3 times 4. Since they're both, since 3 goes into both of them, I want to write them both as 3 times something. I know that 3 over 3 is 1, a big 1, so I have 1 times 1/4, which is just 1/4. Okay, let's come over and look for our choices. And there it is, D, 1/4. Notice that this was multiple choice, and I didn't just look at it and try to pick an answer. I needed to do work. So when you take a multiple choice test or a quiz, or the OAA, or anything that's multiple choice, you're rarely going to just be able to look at the question and find the answer. What you're really going to need to do is work it out on a scrap sheet of paper or off to the side if you have room like we do today, and then pick your answer from there. Question 4. Jaron has 3 red shirts, 4 blue shirts, and 5 white shirts. If he picks one shirt without looking, what is the probability that it will be blue? Hit pause and try this on your own. If you need a hint, my hint to you would be that it's all shirts in his closet, and that's all we're talking about. It's just picking one shirt, so we have one event. Maybe that'll help you if you needed the hint. And if you're just either turning this back on or you want to keep working with me, let's work through this together. So Jaron has 3 red, 4 blue, 5 whites, and he's just picking one shirt. So I want to know how many total shirts does he have. And I'm going to add these. So 3 plus 4 is 7. 7 plus 5 is 12. So altogether he has a total of 12 shirts. He's going to pick one without looking. What is the probability it will be blue? Well, he has 4 blue shirts. So it's going to be the blue. He has 4 shirts that are blue. So that's going to give us 4 out of 12. Remember, we need to simplify this. We can't just leave it like it is. So these are both divisible by 4. So I'm going to write them as 4 times 1 and 4 times 3. When I'm simplifying a fraction, I want to find a number they are both divisible by, and then write it as a product of that. So 4 times 1 is 4, 4 times 3 is 12. Remember that 4 over 4, anything over itself is 1, and 1 times 1/3 is just 1/3. So if we look, it looks like it's A.